So we're going to have this squeeze theorem that I discussed in class. When you're using the squeeze theorem, you're really trying to construct an upper bound function and a lower bound function where the function that you care about is in the middle. So as I explained in the video, a lot of times this occurs when you have a trig function like sine or cosine, because sine or cosine can be bounded between -1 and 1. Okay. So what we did before was we started off with our cosine of x, which is bounded from -1 to 1. And then to achieve the function I actually care about, I had to multiply across by x. So multiply this by x, by this by x, and this by x. And then I get this expression over here. And then I calculated the limit as we went to 0. So negative x goes to 0. You just plug in a 0, right? Positive x also goes to 0. So because x cosine of x is trapped in between, that guy gets squeezed to 0 as well. Number 10 is interesting because I have an odd power of x. So when I have an odd power of x, I actually need to split it into two one-sided limits, because when you multiply through by a negative number, the inequalities reverse. Okay. So if we were to look at our example 6 over here, we're going to do the same type of thing. So the first thing I'm going to do is I'm going to bound, I know that sine of anything is bounded between -1 and 1. That's true for sine of anything. Now I can just write in 21 over x. That doesn't change anything. I want to multiply through by x squared now. And because x squared is a positive number, I don't have to worry about the inequalities flipping. So this is going to become -x squared. This is going to become x squared sine of 21 over x. And this is going to become x squared. Is there any questions about what I just did here? No questions. All right. Now I'm going to take the limit of each of the end pieces. So the lower bound, I'm going as x goes to 0, right? So according to the direct substitution property, this guy goes to 0. Same thing with the right-hand side. According to the direct substitution property, when I substitute in a 0 here, this guy also goes to 0. So the function I care about is trapped in between, so that gets squeezed to 0. So all you got to write is, therefore, by the squeeze theorem, x squared times sine of 21 over x is equal to 0, the limit as x goes to 0. Okay. So squeeze theorem is just this idea that you have bounding function and they both go to the same number, so they both get squeezed down, and then the thing in the middle is trapped.